Okay, so as mentioned, we will be continuing our review of the draft specification. So let me flip over to that. Got entirely too many windows open. Screen sharing is paused. That's interesting. Why is it paused? It doesn't like me sharing Word. Okay, let me try it again. Can anybody see my screen?
Says you had started sharing your screen, but it's still black on my window. Now we can see it.
Now you can see it? Okay.
Mhm.
All right. Okay, good. So last time we left off at protocol properties. So we will we'll continue on from there. So again, just kind of catch everyone up where we were. We were in the this is all the cryptography stuff, and we are specifically talking about the cryptographic protocols part of that. So the first field we have is the type, and the type is an enumeration. So the type of protocol, for example, TLS, SSH, etc. And this is an enumeration of possible strings. We have the version of the protocol. For example, you can combine, for example, TLS and the version, which is perhaps 1.2. So that would communicate that we're using TLS version 1.2. We have the cipher suites themselves, which is an array. And the array has, it's an array of objects, which has a name. It has then an array of algorithms and then an array of identifiers. So the name is, for example, this, right? These are fairly common structures. I know like Java uses these kind of names. OpenSSL uses this kind of format as well. The related algorithms, this is essentially an array of strings, which is the bom-ref to the algorithm that the protocol uses. So again, you would have a separate component for representing the algorithm. So you have a component of type cryptographic assets of subtype algorithm, and then this would be the bom-ref to that algorithm, right? Let's see, a list of this is the cipher suite identifiers. Okay, so this is these are all usually hexadecimal. So this is just how the cipher suite is identified. Every suite has got a different identifier essentially, and this is just an array of those identifiers. Ike v2 transform. So these are all very cryptography specific, I guess, for lack of a better word, but they all map to this particular RFC. So these are not things that CycloneDX created out of thin air. These were all part of RFC 7296. So this is the encryption algorithms, the pseudo-random functions, the identity or integrity algorithms, the key exchange method, the extended sequence number, and the authentication method. Those all, again, map to RFC 7296. And then we've got a breakdown of what each one of these things are, right? So this is an array of the different encoding or encryption algorithms, This is also an array of the pseudo-random functions that are used, an array of the integrity algorithms, an array of the key exchange methods, a Boolean to represent whether or not this is uses an extended sequence number, and IKV2 is also an array of transform types or authentication methods. Let's see, what is this? Cryptographic references. Okay, so cryptographic references, this is a list of protocol-related cryptographic references. Again, this is all going to refer back to the bom-ref, which is why this property is called crypto-ref array. So again, this is going to be an identifier that then links to the other cryptographic asset within the BOM. This description says that you can, use the link can be within the same BOM or it can be across BOMs, which is obviously true. The OID. So in some cases, you're going to have a cryptographic asset, and this is common across all cryptographic assets, not just protocols, which is why it's not in protocols, it's in the cryptographic properties itself. In some cases, you're going to have an OID, which is standard. So this field kind of captures that. And then, of course, we've got the properties, which is the name value pairs again. Let's see, what else do we have? Oh, tags. Tags was added in 1.6 recently. Tags are basically just like these examples. For example, it's not a classifications, like it's not a taxonomy of classifications or anything like that. It really is just, a way to kind of group or categorize different types of components. For example, we've got, a tag that might be JSON parser or object persistence, Hugging Face and similar types of things. There's, AI is eating software. If software is eating the world, AI is eating software. Hugging Face is kind of the biggest kind of repository for a lot of this stuff. Even they don't have a taxonomy. They resort to tags because there's so many different types of things that these models do. So we kind of align to the Hugging Face way of doing this as well, because again, there's just too many different things between software and AI and everything else. There's too many different things. So the tag approach works really, really well for this particular case. Signature. This is all JSON signature format. So none of this is CycloneDX. This actually brings up a good question that we might have to wait for an answer from somebody from Ecma to resolve. But really the question boils down to, this is not our spec. We are simply referring, we've simply captured that spec within CycloneDX. It is my opinion that this particular block of stuff should not be in the CycloneDX spec because it's not ours. In my opinion, we should probably just reference that particular spec, right? And when we reference it, we can also reference the schema along with it. But I think this is going to be a question for Samina and some other folks from Ecma when they return. What are the group's thoughts on this, though? I'm curious. No thoughts?
I guess I don't really have a particular problem with it being an external standard. One of the things that stood out to me that's a little bit strange with the signature area that wasn't obvious from the beginning was we kind of expected it to be the signature of the actual library itself, like the artifact. And it seems to be, intended to be the signature of the JSON and the BOM really signing it.
It is, yeah.
Is there any intention to have ways to capture, similar to what hashes are, cryptographic signatures of the component itself with, something like cosign had signed it, for example?
You can certainly represent, like for example, if something went through SigStore, for example, cosign. You can certainly represent that in like an MBOM, so the formulation that Matt kind of put together. Do we have an external reference for signature? I can't remember, Matt.
Not that I recall. So I had my hand raised, but I don't know if it actually shows up well or not. I think what I see is correct. I mean, we just have fields for documenting fields, and the schema itself is a reference. It's a ref in the schema, so it's always a ref. So I don't see there's a problem or conflict as long as we properly reference that external standard somewhere in the spec in a references section or something like that. I say there's no problem with that at all.
Yeah.
But I don't I've not played with structural level signing. It should work. I'm just, I think that if there's a use case where we can't create a signature, we need an issue, need a test case to figure out why it can't be captured. In one of the two JSF formats. Anyways.
Yeah. So yeah, the signature part here is really for enveloped signing. So signing parts of a document, because complex software and systems, you might actually have different signatures in a single document from different suppliers, right? It's very, very common use case. So we're able to capture all of that in CycloneDX, which is completely independent of the signature of the document itself. The signature of the document is just one big blob, right?
Exactly.
This is finer grained.
In the case of SigStore and cosign, I mean, those are external references basically. So you're pointing to record, pointing to a transparency log entry, and that will have references to the signing there. So I'm not sure how or where we'd capture a client cosign. It doesn't. I mean, I can't conceive of the use case. You can capture those things in your, as Steve pointed out, if you want to in your data flow. Maybe it's imperfect, but we're at the early stages of manufacturing BOM. But there are, every place we have properties and external references. If there's a better way to do it that is industry accepted, let's do it for the next release.
Yeah, we do have a way in external references to capture digital signature. So this can be used anywhere that external references are supported, which is also at the component level, right? So theoretically, you can link out to a URL that does have the external signature of that particular component. So that is a supported use case today.
Perfect. That's exactly what we'd probably be looking for. So thanks for taking the time to discuss that.
Yeah, of course, of course. So if there's no objections, I'm going to skip the signature part again because it's JSF and not Cyclone.
No objection for me.
Okay. Let's see, where does the signature stuff end? I believe there's a new ISO standard for JSON signatures too that I just saw like a couple of months ago. So for a future version of Cyclone, we might want to look into that. Ooh, services. On to something new. All right, services. This is, well, a list of services. So we talked a lot about components, right? And software, hardware components, ML, etc. These are services. These are things that they're not components, but they're still part of your inventory. So these are things like microservices, lambdas, that sort of thing. You can also capture intra-process services as well. these are the list of the properties, and we're going to go through all of these, so bear with me. The first one is obviously the bom-ref. So again, every service is going to have a potentially a unique identifier. A service doesn't have like a it has some different fields for like things that are unique to a service, like a provider, for example. Who's the provider of the service? So this, again, this is going to use that same organization structure that we've looked at a lot. I need to figure out a way to kind of pull that out of the document and make it reusable, so it's not in here 50 different times. But this is that same organization structure that we've looked at. So the organization name and address and locality and that sort of thing. So I'm just going to skip all this. If I do limit, or if I do reuse that, though, that's going to really reduce the amount of pages, which will be great. Just like a component has a higher level group, the services also has a group. This is usually something like a domain name or some kind of namespace to help identify, who that manufacturer or supplier is, right? This is the name of the service. For example, I have a stock ticker service as kind of an example. The version of the service, brief description of what the service is. Endpoints. Endpoints are basically all the URIs that you can use to communicate with that service, whether it's HTTP, whether it's MQTT, or some other protocol is kind of irrelevant. It's protocol agnostic, so all the URIs to that service. Whether or not authentication is required or not. I would love to be able to expand this in the future, in a future version of CycloneDX, so that we actually capture the authentication requirements themselves. But right now, we just have a Boolean. We also have a Boolean to represent whether or not going to the trust or going to that service, typically from a component, crosses any kind of trust boundary or not. And again, this is a Boolean. However, we can also specify the trust zone itself. So, for example, a component. One example that I always use is I might have a convenience library. My application uses a convenience library where I pass a stock ticker to the library, and the library magically returns the stock quotes for, I don't know, IBM, ServiceNow, Microsoft, whoever. Well, obviously the library doesn't make up the tickers or the values itself. It relies on some kind of service, right? Well, within the context of my application, my component is going to be within that same trust zone as my application. However, my service is not, right? My service actually crosses that trust boundary. So in that particular case, I might have two different trust zones, one for my application, one for my public facing, stock service ticker thing. And obviously that does in fact cross the trust boundary. This is a description of the data going to and from the service. So the data is an object, and we can capture the flow. This is the directional flow of data, the data classification, the name of the data, a description, governance, which we've looked at previously on the ML and some other stuff. And then you can link the service to and from the source and destination to and from other components in the BOM. So the directional flow, for example, I might have data going into a service or coming out of the service. I can have data classifications. For example, I might have a data classification of confidential or restricted or public or whatever the case is. I can have a name of the data and description of the data. Data governance, these are the stewards, the custodians, and owners of the data. Again, this is all that organization and contact information. So I'm going to skip that because it's all repeat. Let's see, governance. We're still in governance. We're still in governance. Still in governance. Boy, this would really reduce the amount of pages if I can clean this up. Okay, governance ends here. The data does have the option, you can specify a source and destination. So if data is going outbound, maybe that's the flow. Well, you can specify the destination to where that data goes to. For example, that service, the output of one service might be the input of another service or another application, right? So you can actually use the services, the data, and the source and destination to actually create data flow diagrams and represent those data flow diagrams in the bill of material itself. Let's see, licenses. We've talked about these before, and that is interesting. Jan, can you make a note of this? It's using the title from the component licenses, which is weird, in the services section. So if you can make a note of that, I would appreciate it. Okay, I'm not going to go through this. We've gone through all the licensing stuff previously. License. This is also a really big section I need to pull out. Okay, here we go. Okay, so all right, so external references. We've talked about these before. Services can contain other services. That is a thing. However, it's a little bit different with the service. In our kind of view, these are things that are typically deployed behind parent service. So for example, you know, from a inside out look, or from an outside in look, you might actually have an API gateway, for example, that you're actually interacting with. But behind that gateway, you have the actual services that power that particular application, right? So that would be one way that you might want to group these things together. So CycloneDX allows you to nest these things. Release notes we talked about, I think it was last week or the week before. So I'm going to skip that because services also can have release notes. Hey, Lars, welcome. Glad you found us.
Hi there. Sorry, yeah, I'm in the bus and kind of missed this, so.
Yeah, no worries. Okay, so properties again. So these are the name value pairs. Services can also have tags. So we just talked about tags previously on the components. And then we can sign this block. So we talked about JSF also just previously. So I'm going to skip the JSF part because we will pull this out most likely. And what's after? This is the end of services. External references themselves. I can't remember if we actually went through all the external references or not. But let's just go ahead and go through it real quick. External references are interesting. They really allow us to document things that are, well, external to the BOM or external to that component, but they also allow us to form relationships. So in CycloneDX, an external reference actually serves both purposes. and which is very, very different than that other BOM format. And certainly makes it unique to Cyclone. So for external references, you can have a URL, and this is really a URI because it can be like an external thing. It can be any of these RFCs we have examples to, or it can be the CycloneDX BOM link, which is a thing that actually establishes relationships either in the same BOM or across BOMs. So that's how relationships are formed. We have a comment, the type, which is an enumeration. We'll look at the enumeration. And then the external references can also have optional hashes as well. So the URI or the URL, pretty self-explanatory. Comment. These are the different types. So this is, again, this is just an enumeration of all the different types of external references that we support. So, for example, there is a, let's just take an example. Here's an example I use a lot, actually. So theoretically, you could have a threat model, right? You can have a service or component that has an external reference to that threat model. And yeah, it might actually be maybe a PDF that's on a web server somewhere, or it might actually be a data component that's excluded from the inventory, represented in the BOM, and the threat model is literally like represented in the bill of material itself, and you are linking these two things together with an external reference. I think that's one of the examples in the authoritative guide to SBOM. But these are all the different types. And to Keith's earlier question, we've got two different types of signatures. We support not only digital signatures, which I believe was your original question, Keith, but we also support electronic signatures, and we have to support that case, which is more of an analog signature, really. We have to support that case for the attestation support, because PKI infrastructure typically doesn't roll up to CEOs of companies and stuff like that. It's non-existent. So we support electronic signatures as well. But for your case that you were asking about earlier, you would just literally provide the external reference for any of your components or the BOM itself and reference that external signature. Obviously, you don't want these things changing without your knowledge, right? If you are, for example, linking out to a digital signature that is external, or some other kind of artifact, a threat model perhaps, capturing the hashes of those things, probably a good idea. That way you know whether or not it has actually been modified. Optional, but highly recommended in some cases. So obviously these are the different hashing algorithms that we support and that we've talked about previously. Okay, on to dependencies. So dependencies provide a way to document relationships, depends on types of relationships, right? Dependencies is an array, and every dependency can have, every dependency must have a ref. So this is the thing that the dependency relies on, whether it's a component or service. And then we have two different ways to kind of form these relationships. The most common way is using the depends on. I have a component that depends on another component. But in the case of cryptography, we also have a provides. For example, this library provides this algorithm. But most of the dependency stuff you're going to see is the depends on, which is simply an array of all the other BOM refs in the BOM that the component depends on, right? Likewise, you can also, if you use provides, for example, I might have, for example, Bouncy Castle, which is a Java cryptographic library. I might have a thing, and well, that maybe my application depends on Bouncy Castle, and Bouncy Castle provides all these different algorithms that are also in my BOM, right? That's kind of the use case for how both of these kind of work together. And provides also is just an array of the BOM refs. Compositions. Compositions are interesting. They kind of allow us to represent the completeness of certain things. This goes back to some of the early NTIA discussions where the concept of known unknowns was talked about quite a lot. We've since moved on from known unknowns to more known knowns and some other kinds of use cases as well. But the compositions basically allow us to provide descriptions of the completeness of certain things. Each composition can have an identifier, the BOM ref. Each composition basically has an aggregate, which is we'll get into this in just a bit, which is an enumeration of strings. You can represent the components or services assemblies, whether it's a single component or service or a nested group of components or services. Those are the assemblies. The dependencies, you can describe the completeness of those. You can describe the completeness of vulnerabilities, which is also an interesting use case. So the aggregate, we've got some choices here. We can say that this thing is complete, right? I might have, I don't know, maybe the entire inventory of my BOM, or maybe just I'm only representing the completeness of a particular library, right? I can say, well, I'm only using Bouncy Castle, and Bouncy Castle is complete. It doesn't have anything else that's kind of shipped with it, right? So I can say that single component is complete, or I can say it on the BOM itself, right? I can say that things are incomplete, and there's a couple different reasons why things might be incomplete that we also support. Most common one is this one right here: incomplete first-party incomplete third-party open source only is the most common. So a lot of suppliers simply want to communicate only the open source components that are distributed with their product, right? They don't want to communicate the first-party components that they've built themselves, nor do they want to convey the commercial or proprietary components that are also delivered with their software. Usually this involves some kind of NDA or contract preventing them from doing so. So this one is certainly the most common one used. But there's a lot of use cases for like first party only and some of these other ones as well. Obviously we support an unknown and not specified, which is kind of the default. The assemblies, like I said earlier, this is basically a single or a nested group of components or services. The dependencies, so you can describe the completeness, for example, of a single part of the dependency graph, or the dependency graph as a whole, right? So you can get really, really granular if you want to. You can describe the completeness of the vulnerabilities. And this is something that I think VEX and VDR is kind of, this is really important to these concepts, right? Of VDR, for example, which is essentially the assertion of vulnerabilities that are affecting a product. Well, you can represent the completeness of that assertion, right? You can say, well, this thing is, my assertion of the vulnerabilities is complete, or I can assert that, going back to the types, my assertion of vulnerabilities is only for the open source vulnerabilities, not my first party vulnerabilities, right? Or I can do just the opposite, right? Maybe I want to convey only the first party vulnerabilities that that are in my product, right? So you have a lot of interesting use cases that you can achieve by having this level of granularity. And then of course, everything can be signed, right? So again, I'm going to skip the JSF stuff. And on to vulnerabilities themselves. Grab a sip of water here. So vulnerabilities are then identified in the components or services. We're going to go through all these different properties, but there's a lot of them. So we're not going to get through all these today, I don't think, but that's fine. I think we're making some good progress though. So like everything, you can have an identifier, a bom-ref, for the individual vulnerability. The ID of the vulnerability. This is typically the ID that is used in the source of vulnerability intelligence that you're using. For example, National Vulnerability Database, or maybe GitHub Security Advisories, or Sneak, for example. So this is really the identifier as those particular systems use it. The source, this describes the source of vulnerability intelligence. So you've got the URL, for example, which in this case is the NVD, the name of the source. So some examples of sources here. And then we use that same concept for references. So references are essentially aliases, I guess. You can refer to them as like aliases. So, you know, like this Sneak, I think I think this example is actually, I'm not sure if these are all the same or not, but different sources of vulnerability intelligence, while they might have their own identifier, they might also be identified as something else, a different identifier in a different source of vulnerability intelligence. The most common one is to have like a GitHub security advisory, and a unique number for that, but that also is in the National Vulnerability Database, and you have a CVE for that. So that's really what the references is for. So you can say, well, here's the ID of the vulnerability that I'm describing, and here are the references. Here is what it's called in other sources of vulnerability intelligence, and we have the ID, and we have the source of that source of vulnerability intelligence. Ratings. So ratings are a way to group both severity and risk ratings kind of together. So we have a couple different fields here that we're going to go through. Number one is the source. Oops, what happened? Okay. Number one is the source of the risk rating. So this might, for example, be the National Vulnerability Database, or it might be Acme Incorporated, whomever. The URL to that source, the name, etc. What the actual score is, right? I might have a CVSS score of like 10.0, right? Extremely exploitable. Well, I can represent that score here. I can also represent the textual representation of that severity here, right? Because not all numerical scores use the same breakdown of what's critical, high, medium, low, etc. So we can represent the textual representation of that here. We have different methods of severity and risk scoring. Obviously, CVSS and all the different versions of CVSS are supported. We also support OWASP risk rating, as well as the stakeholder-specific vulnerability categorization, which is literally CVSS spelled backwards. And then, of course, if you have your own, if you have your own severity or risk rating methodology that you use, you can add that here. All of these have one thing in common. They all use the concept of a vector, so that if you wanted to find out how a certain source, how they actually rated something, the vector is the kind of the way to do that. Keith, you had a hand up?
Yeah, is things like EPSS scores, is that intended to just be an other? They're sort of more of a like exploitability rather than a severity rating. Would that belong under this sort of severity rating area?
You could put EPSS in there. I mean, we don't support it out of the box because EPSS changes literally every 24 hours. So that really kind of limits the usefulness of that field. But yeah, you can put EPSS scores in there. I think EPSS has two different scores, however. I mean, you've got the exploitability, which is like a 0 to 1. And then there's that other field as well. I can't remember what it was. But because EPSS is, I don't know, again, it has the potential to change every 24 hours. You know, I think it would be best served as maybe an API representation of Cyclone versus like a CycloneDX document, because once you have the document, it's basically going to be out of date the next day.
That makes sense.
But yeah, you can use it. You can use other. And with that, we are at time. So thank you all for bearing with me. Thank you all for finding the new Zoom link. And if you have any questions, I know we covered a lot here. If you have any questions on all the stuff that we've covered, please reach out on the Slack channel, and we can get those questions answered. So with that, have a great rest of your day. Recording will be published later today. So have a good one. Cheers.
Really quick, is that Zoom link intended to be the one going forward? I think he already dropped off.